Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest's Sciences and Mathematics TV channel. Today we're going to look at an aspect in the cylindrical coordinate system, and this basically is going to complement on the two first videos that we've done on the spherical coordinate system and the rectangular coordinate systems respectively. So basically our discussion today is going to be centered around the differential elements. And these are going to assist us, of course, try to locate certain differential aspect of the cylindrical coordinate systems. Now, on my right and left, I've done two figures. Of course, they are congested, but I'm going to try my best and try to see, of course, how I can be able to be elaborate on the various aspects of this differential element. Now, we had said that we can be able to consider a point in a cylindrical coordinate system, a point P. And we say that a cylindrical coordinate system is made up of surfaces which are going to be, of course, made a radius of r. So that's going to form a variable for r given as such. And then next we say that there's going to be an angle that is going to be formed by an extension of the plane, the half plane from the point of zx plane towards the right side, of course, that is going to form. If my orientation was from this specific point, I'm going to consider the zx plane to be at this specific point. So that an increment towards the right side of this is going to form an angle pi. And of course, this plane that is being extended is going to be, of course, perpendicular to the y plane given as such. So that's going to give us an angle phi, which is a second surface that is going to form the cylindrical coordinate system. And then lastly, we talked about the concept of the z-axis, which is going to be given as a constant as well, given as such. So an increment in these three aspects or surfaces of the cylindrical coordinate system is going to form a differential elements. So therefore, we are going to have this increment being given as a dr, a d phi. So an increment from a point P of those various elements, we're going to have it perhaps located at a new point of intersection between these three surfaces. And I'm going to allocate that point or give it as a P prime. So therefore, we can be able to give the coordinates of that P prime as r plus dr. And then we're going to have phi plus d phi. And then we're going to have the last one for z as z plus dz. Respectively. So therefore, this is going to define a new point of intersection for those three specific surfaces for the radius, the z plane, and then we're going to have this specific half plane, which is defined by phi given as such. So we can be able to illustrate these specific increments on my right. Let me give this one as A and B. So we are just going to go on a slow rate so that we can be able to pinpoint this. So if we try to consider the concept of a radius, if we try to look at this specific point of origin, I'm going to assume that this is going to form my first part of this extension for a radius. So from the point of origin to this specific point, that is going to form my radius of r. So an extension from this O to this specific point is going to form a new radius, which is going to be indicated as r plus dr, which is my first part of the variable I've given as such for the point P prime. So the second aspect is an extension of an angle. So this is going to have a net effect of extending a point radio from this specific point at the center, if you consider this one to be a surface. So therefore, it's going to constitute this a specific increment, and therefore, we're going to allocate it at a specific volume in space as a dr given as such. So that's going to cater for that. And then we are going to have this specific extension of a half plane from phi to d phi plus, so from phi to phi plus d phi. So our first extension or our first position for this point of P from this specific zx plane was at this specific point for r. So an extension by this specific set from phi plus d phi is going to give us a new point that is going to be given as phi plus d phi. So if I try to look at this, then therefore this is going to give me a set of this particular extension of an angle given as such. So I'm going to have this one being given as a distance from this specific point. So the new location of that second plane is going to be at this specific point. And then for z, we're going to see that for the first point, if you try to consider a first point for P at this specific point, then there's going to be a definition of a Z plane located, which is a constant at this specific point from the origin at this point. If this is my point P, the Z plane is going to be located at this point. If we have an increment in the Z, which is going to be defined as dz, then therefore that's going to give me a total length of z plus dz, which is going to be located at this. So a combination of these 3 points are going to allocate what we call a p prime. And as we said, of course, we're going to be able to define a vector that is going to represent that specific increment. And of course, as we said, for the concept of a phi and of course these other differential lengths that we have given for r and z is going to be an angle in that specific case and not a length. So therefore, we can be able to describe this differential length and of course the extension in that specific angle in terms of a differential vector, as we have done for the first two aspects for the spherical and the Cartesian coordinate system. So we're going to define this of course the vector, differential vector length using the dr, and then we're going to have that base angle plus d phi, and then we're going to have a phi, and then plus dz, and then we're going to have az given as that. So those are going to define a differential vector length, and of course its magnitude is going to be given as the magnitude of so this dl, differential vector length. So the magnitude of this differential vector length is going to be given as the square of dr plus the square of. So for the second one, this is going to be given as of course we had defined this service. The second service we had defined it as r d phi, which is basically going to be given as this one. So we're going to do a rectification for that. So this is going to be a square of r d phi given as such, and then plus the last one we're going to have it as the square of dz given as such. And so this one is going to be the root of the all of that particular sum of those three specific elements, and that's going to give us the magnitude over this differential vector length that I've mentioned. And this, of course, the interaction between these three planes, or the transition between P and P prime, is going to give us what we call three new sets of services. And together, they are going to form 6 sets of services, which are going to give us a differential volume, which we had mentioned. So therefore, we can as well define this differential volume in terms of dV. So dV is going to be given using those various aspects for r, dr, and then that's going to be the product of d phi, dz, given as such. So this basically implies the volume of this differential interaction of these 6 planes. This basically implies the differential of, or rather the volume of this specific case. If you try to look at this, we are going to have this one as demarcated from our normal geometry. dz will be our height, and dr will be our length, of course, and we can be able to have r d phi. So this is r d phi given as our baby breadth, if we can be able to give it in terms of that. So we have these 3 specific elements for this one given as such. So r d phi is going to give this specific length that I've indicated for the arrow. dr is going to give this specific breadth, and then we have dz for the height given as such, and those are going to give us a combination of those are going to give us a differential volume of that specific cylindrical coordinate system. So for the various service elements that I've indicated, of course, they are similar to the first ones that we had said, but they are not going, all of them are not going to assume that specific flat aspect. Of course, they are going to have a curvature services, but for the sake of illustration, I've given them in terms of flat services indicated as such. Of course, we're going also to see that we can be able to demonstrate the differential vector services of that are normal to r direction using those specific products for dz, rd, phi for the first one, together with its specific base vector ar given as such. So for instance, I'm just going to give for the first one. So we can be able to illustrate this differential service element for SR, using that product for what we have referred to as RD phi, and then so the RD phi, and then we're going to have a DZ given as such. So RD phi times DZ, we're going to give that one. So that one is going to be accompanied by its respective vector, base vector that I've given for that. So that's the same procedure that we're going to use in trying to allocate the differential vector services of the other remaining two elements. So this is going to be the last bit, and of course the final part of the differential elements of the coordinate systems. So check in our description boxes for various links for other videos that we have done on the same, which are going to assist us, of course, differentiate between the three. And as I said, these are going to be very relevant, especially in trying to interpret various areas of electromagnetics, etc. So that is it for now, guys. Bye. God bless you.